An ESP32 with display, 2 breadboards, 1 cardboard where everything is glued on, and 2 hooks? Okay, I know what you're thinking. Peak ingenuity. I get it. However, this is a great opportunity to experiment with sensors. Well, let's try. The first thing I've done is install Platform.io extension into my Visual Studio Code, and yes, I accept the publisher. In the future, I might have some similar projects about microcontrollers, therefore I create an organization for all of these repos. I create my repo with the MIT license and clone the existing repo into my local machine. And don't forget the gitignore. After pulling the project from GitHub to my local machine, I have to use the Platform.io extension to create a new project in the exact same location with the exact same name. With the boards, I'm going with ESP32 dev. This is what you're going to need most of the time. And with the framework, I'm going with Arduino to keep things as simple as possible. After that, the extension is creating the necessary files. Just wait for a bit. Alright, before we continue with this setup hell, let us see what the Platform.io extension has generated us. Even though, admittingly, I already programmed a little bit in the following clip. First, there's the platform.ini, which is your project configuration file, like for example the libraries you wish to use. In the source folder, there is the main.cpp, which gets executed the moment your microcontroller gets power. This is split up into setup function, which gets executed once, and the loop function, which gets executed continuously, as long there is power. In PioHome, you can see the ports where your microcontroller is connected to. In my case, it's COM3. Next, I have to build the project and hope it is a success. During the build, your code gets turned into an executable binary that the microcontroller can execute immediately. And then there is the flash process, during which the compiled binary code is being put into your microcontroller. Some ESP32 boards don't flash automatically. For that, you have to press the boot button to allow the upload. The moment the code has been uploaded, it gets executed immediately, like you see here. Yes, it works. And let's not forget to push the changes to Git so that I don't lose my progress again. After a little bit of tinkering, this is what we are working with. This ESP32 model was too big for one breadboard, therefore I used 2 breadboards with each their own voltage line indicated by these yellow LEDs and capacitors to smooth out the voltage fluctuations, which is technically not necessary in my case. The brown lines are GPIO pins that work for input and output, while the orange lines are only for input, preferably analog. On top of that, I have an enable button to conveniently reset the ESP32. As you can see, the moment I press on the enable button, the counter gets reset. Well, technically, I mean the enable pin and not the button, because the button is unspecific, but you know what I mean. This right now is the base build, which means this is the point where we can add the sensors or experiment with it however we want. My base build at the software side looks kind of like this, where I import all the code that I have written and then call these functions in the setup and the loop and try to keep it as concise and clean and necessary as possible. In the main CPP, you only include the header files, which have the function definitions, while in the CPP files, they contain the implementation. It's a C++ feature which separates between the definition, which are in the header files, and the implementation, which is in the CPP files. Except for the main.cpp, this is the start of the entire program and doesn't need a header. After hours of setup hell, tinkering and programming for a bit, I can finally start with the part I was actually trying to do: sensors. In this case, I'm using sensor modules from an inexpensive set that I got online. The first sensor is the DHT11 for measuring humidity and temperature. After some research, I found out that it's not precise, however, it's still good enough for a proof of concept. The sensor pin is connected to a GPIO pin. and the other 2 pins are connected to ground and VCC. Then there is the LDR, the light dependent resistor. Its internal resistance gets lower the higher the light intensity is. This can be measured by using the GPIO pins for analog input only. And these are the values. As you can see, the numerical output of the LDR increases and decreases depending whether I put my finger on the sensor or not. Here again, I know it is not precise, but at the very least it's good enough for a proof of concept. And just to show how the software side looks like, in the main file I have my setup where I initialize all the sensors, and the loop where I constantly access the sensor pin data and display them. To keep the program scalable and modular, every sensor gets its own file. Under Pio Home and Libraries, you can search for specific libraries that you sometimes need to include to use specific sensors. Like in this case, I'm adding a library for my DHT sensor. It's now in the platform.ini file and I can use it for the entire project. Oh, and let's not forget the display function that shows us the results. And to address the elephant in the room, the hooks on the cardboard are meant originally to hang the entire ESP32 and therefore save space. But that plan has been on hold for now. Nonetheless, it was nice getting back into electronics and microcontrollers after an entire year. I'm just glad the sensors even worked at this point. So yeah, I think I have enough for this week. So until next time, and bye.